Sometimes math can feel like this secret language, right? Well, today, we're going to crack the code on one of its most powerful ideas, functions. And forget about dry formulas. Think of them more like hidden rules that create patterns all around us. We're about to figure out how to spot them, give them a name, and even find them in your everyday life.
Okay, let's just jump right in with a little puzzle. Look at this. If 3 turns into 6, and 4 turns into 8, and 5 turns into 10, what's going on there? What's the hidden rule, the secret instruction that connects these numbers? Think about it for a second. We're about to crack it together.
All right, first up, let's officially spot that hidden pattern. So, to get organized, we have to give these columns some official names. The numbers we start with, the 3, 4, and 5, we call that the domain. That's our input. And the results we get, the 6, 8, and 10, that's the range, our output. Simple, right? Domain goes in, range comes out.
And there it is, the big reveal. This process column shows us the secret. To get from 3 to 6, we just multiply by 2. From 4 to 8, same deal. From 5 to 10, yep, you guessed it, multiply by 2 again. That simple, consistent action, that's the hidden pattern we were looking for.
Okay, so we found the pattern. Now let's give it a proper name. It's time to decode the function rule. Now, function rule. I know, it sounds a little intimidating, but it's not. It's really just the recipe. It's the one single instruction that tells you how to turn any number from the domain into its partner in the range. It's the heart of the code.
And this is what that recipe looks like when we write it in math language. Y equals 2x. All this is saying is that your output, which we call y, is always going to be 2 times your input, which we call x. See? It's just a super fast way of writing take a number and double it.
So let's lock this in. In the world of functions, our inputs, the numbers from the domain, we just call those the x values. And our outputs, the numbers in the range, those are our y values. You put in an x, you get out a y. That's the whole system.
Okay, so this is cool and all, but where do you actually see this stuff? Like, in the real world? Let's take a look at functions in your daily life.
Think about something you probably deal with every single month, your cell phone bill. That final number you have to pay? It's not just random, it's calculated by a function. There's a specific rule connecting how much you use your phone to how much you pay.
A lot of these real-world rules have a starting point. We call it an initial value. For your phone bill, that's your monthly flat fee. The amount you pay even if you don't make a single call. It's the part of the function that doesn't change. And check this out. This table shows that rule in action. See? At 495 minutes, the cost is just that base rate, $29.99. But as soon as you go over that, look what happens. The cost starts to go up. The minutes you use, our domain, are directly changing the total cost, our range. This brings up 2 more really useful terms. The minutes you use, that's the independent variable. Why? Because you control it. You decide how much you talk. The total cost, that's the dependent variable, because it depends on how many minutes you used. Your usage is literally driving the final cost. Okay, so these rules describe patterns, right? But here's where it gets really, really cool. We can actually see these rules. It's time to look at a picture of a rule.
Yeah, that's right. These abstract rules have a visual identity. When you take all the possible inputs and outputs of a function and you plot them on a graph, they create a shape. It's almost like a visual signature for that specific rule.
So let's go back to that very first rule we cracked, y equals 2x. This is what we call a linear function. And when we draw its visual signature, we get a perfect straight line. Makes sense, right? The pattern is so consistent and predictable, its picture is just as simple and direct. That's actually why we call it linear. It literally makes a line. But what happens if we just tweak that rule a tiny bit? What if, instead of multiplying by 2, we multiply a number by itself? So, y equals x squared. This is called a quadratic function. And its shape, well, it's completely different. It doesn't make a line at all. It creates this really cool, smooth U-shape that we call a parabola. Isn't that amazing? We change one little thing in the algebra, and it completely transforms the geometry, the shape. And this isn't just a fun fact. These shapes actually predict things in the real world. That curve can map the exact path of a ball you throw through the air. Okay, you've seen how to crack the code. Now it's your turn. All right, quick challenge. Think about getting paid for a job. Your total wages are based on the hours you worked. So between your wages and your hours, which one is in control? Which one is the independent variable?
You got it. The independent variable is the hours you worked, because you control that. Your wages are the dependent variable, because the amount you earn depends completely on how many hours you clock in. More hours, more wages. See? You've totally got this.
So, let's wrap this up with the key takeaways. 1. A function rule is nothing more than the recipe for a pattern. 2. The domain is what you put in, the range is what you get out. And 3, probably the most important part, these patterns aren't just in a math book. They're literally everywhere, from your phone bill to your paycheck.
You know, we started this whole thing by talking about cracking a toad. Well, now you've got the key. So the real question is, as you go about your day, what hidden patterns, what secret function rules are you going to start seeing now that you know what to look for?